particle diagram analysis. I was getting some questions on this page, so I thought let's make a video and hopefully that will make things a little bit clearer. So if you remember back to the beginning of this week when we started discussing the difference in matter and classifying things as element, compound, and mixture, we were looking at real objects, and we call those real objects the macro level of something when you're just observing your sample. But we also have the micro level where you consider what the particles and atoms would look like at the atomic level, and that's what we're looking at today. So when we look at a picture, it is representing on the atomic level what our compound, element, or mixture might look like. So using our key, we're going to break down what these pictures look like. So our key says an atom is each shape, an element are the shape variations, color, size, form. A bond is where shapes touch. A particle is a distinct grouping. A pure substance is in the picture all particles are identical. In a mixture, all particles in the sample are not identical. Our directions here say for each particle diagram, identify the number of particles, atoms, bonds, and elements. Then determine whether the sample is a pure substance or a mixture. Let's take a look at this first picture for number 1. We said that an atom is each shape. Let's just count our shapes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total circles in this picture. 10 atoms. Elements are the shape variations. We have 2 different elements in this particle diagram. We have the larger white circle and the smaller black circle. So there are 2 elements present. Bonds are where shapes touch. So we have 1, 2, 3, 4, 5 different chemical bonds holding together our particles. That leads us to particle. Particles are distinct groupings where there's nothing else touching it other than the things that are bonded together within. I'm going to circle our particles. We've got 1 here. Notice how that particular grouping is not touching anything else. Same with this guy, this guy, this guy, this guy. Sometimes those are also called molecules. For this particular worksheet, we're calling them particles. So I circled 1, 2, 3, 4, 5 particles. Now the last part is determining whether it's a pure substance or a mixture. Check all 5 of your particles. Are they the same? They might be in a different orientation, but yes, they are all composed of a large white circle and a small black circle. So this would be a pure substance. We can take this one step further and break down pure substance into element and compound. This particle diagram is representing a compound because it is made up of multiple atom types bonded together in a set ratio. White circle, black circle. That's each particle. If they were all black circle, then it would be element. We need to have all the same shape variation in order for it to be an element. Compounds can have different types of atoms bonded together in a set ratio as long as the particles are all identical. Okay, so let's take a look at another problem. Let's do number 4 here. Same process. Let's count. Looks like we have 2 different types of particles here. So we've got this Mickey Mouse looking one and then this circle. So we have 2 different types of particles, but total particles, we have 3 of the Mickey Mouse ones and 3 of the white ones. So that would be 6 total particles. Elements. We have 3 variations of shapes. We got the big circle, we got the tiny black one, and we got the tiny white one. So 3 elements present. Total atoms, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3 on each Mickey Mouse, and then the individual 3. And bonds, 2 per Mickey Mouse. That would be 6. Okay? Are all of the particles identical? Well, we started off saying we have 2 different types of particles, so no, they're not. We have a mixture. And if we were to go one step further, we would say this is a mixture of a compound and an element. A mixture of compounds and elements. When you break them down at the particle level, you see the Mickey Mouse is a compound and the individual white circle is an element. So this would be a mixture of compounds and elements. On the back side, after you go through all of those, you have some questions to answer with your analysis. For number 10, this is taking a look at chemical formulas and pairing them up with the pictures on the front. So each element symbol is representing a shape variation, and they will match as you look for patterns. Remember, we talked about capital letters mark the start of a new element, and then our numbers are going to tell us how many of them. So let's start with A, Na5Cl5. This is all one particle because it's all grouped together. And we have 5 of one shape and 5 of another shape. Take a look at all of our pictures here. Looks like number 5. One big particle, 5 of one element, 5 of another element. So this would be particle diagram number 5. Let's also look at 7 Na. So we want to find 7 of a certain shape. It's just that one shape. Looks like 8. Okay. So there's how you do number 10 and number 11. Then as you go through it, you could even do it at the same time you're going through it. Draw the shape variation used to represent each element. So in that one we just had the white circles, that would be Na. And looks like Cl is the little black circles from our first example. It is consistent throughout all of the particle diagrams, so once you draw one, it will be true still. The biggest difference you'll see in our shapes are size and color. They're all circles, so don't get confused with number 11. There are differences for each of those elements. And then number 12, you're just breaking down and decoding the parts of a chemical formula. On the next 2 pages, you're doing the same process that you did on the first page, but now you are doing a little bit more specific. Instead of pure substance and mixture only, you're doing compound, element, diatomic element, mixture of compounds, mixture of elements, mixture of compounds, and elements. Diatomic element, let me remind you, is when you have 2 of the same that are kind of twin pairs. So if this was my particle diagram, all of them are the same and they're the same shape, but they're twinned up, that would be a diatomic element. Now if one of these was colored, now it's a compound. It's no longer a diatomic element. So just be aware of that. This would be a compound. How it was written before would be a diatomic element whenever you have those twin elements. Okay, so let's just do the first few together. Look at the particles, if that helps you. These are all identical and they're all twinned up, same shape. This is a diatomic element. These are twinned up, but they're different. They're actually not, because they're different shape types, which means these are different elements that are bonded together in a set ratio, black-white. This is a compound, but it's still pure because all of our particles are the same. And number 3, we have this particle type, we have this particle type. So our particles are different. That means it's a mixture. And both of them are compounds. Mixture of compounds. Ta-da! That's what you'll do for page 11 and 12.